Hello and welcome to Console Cowboys. So today we're going to take a look at 3 different binaries. And we're going to utilize AI in different forms to understand what's going on. We're going to look at things manually via assembly. We're going to mark up C code. We're going to create key generators. And we are going to understand complicated algorithms both manually and utilizing AI to help us along the way and augment that process. So if that sounds good to you, stick around and we will get started. I have the first binary open in Binary Ninja, and I'm in the start function, and that is this code right here. So in this first binary, we're going to take more of a manual approach to reverse engineering and assembly because you need to understand how to do that first before you mess around with the decompiled code. And then we're going to use a little bit of AI to understand the assembly if we didn't understand what was going on. So to get started, we're in this start function. Now, towards the end of a start function, you'll generally see a call to main, and we do. However, it might not always be labeled main if during the analysis of the application opening the program, it didn't determine that. So you're going to look for something towards the end of the start function that looks like programmer-defined code, because there might be multiple calls in here. In this case, we have one call to libstart main. We dump main, we load it into RDI, and we call that. So we're going to take a look here at a few different items to determine what it's doing. So first off, what type of arguments are being passed in here or variables, and then what types of strings can we actually understand in here that might be useful to us, as well as what calls are being made and how the data is being processed. So to start off, this is the main function, so we have argc and argv. We also see something for environment pointers. So the first thing we see is a push to R12, and that's saved on here, and that is probably our argument being passed into this function. And then we have some strings. So we have an input string using a format specifier. We also have a ulose and a uwin, which means there's probably some code in here that's making some decision on whether you lose or whether you win. Now we have some calls to printf, which is probably printing this along with whatever argument we sent in. And then we have a call to a subroutine function that is probably going to be used in determining whether we jump to you lose or you win. Now if I hit the space bar, I can see this flow here. And again, we have our input. We get to a jump not equals to that is probably based off of the results of this. And we go to you win or we go to you lose. So that's just the gist of how it flows. Now let's take a look at how it actually runs in the terminal. So if I go to keygen_me1 and I hit enter, nothing happens. So if I type in a value after it, which would be our first argument, we get back input test. So that test would be coming from that format specifier string and the input you saw right within the assembly code. And then we see the you lose because we put in the wrong value. So really what we need to determine now is what happens in that subroutine. So if we hop into this function, we could take a look. We have an argument coming in. That argument would be associated with RDI, which goes into RBX. Now when you highlight RBX, you're going to see that it's used throughout this function. What is it being used for? It's being used to compare a byte of RBX to various values. So the byte of RBX is being compared to hex 77. RBX plus 1, which would be the next value in that string, to 68. RBX plus 2, the value following that one, being compared to hex 61. So it's comparing the values of our string to potentially check that our string is equal to this string. But before it does all of that, once it goes into RBX, it's being used in a call to string length. The value comes back into RAX, and it gets put into R8. R8 is compared with 5. So we're comparing whether our argument that went in is equal to 5. And then if it's not equal to 5, which we also see a lot of other not equals, it's going to be sent to this value here, which all of these are also being sent there. So what is that value? If we scroll down, that is just leaving the function. We're popping RBX and we're returning to main. So none of this code is going to be run if it's not equal to 5, or somewhere throughout here it fails our checks. Okay, so we have some key information to this assembly. 1, our value being passed in has to be equal to 5, and then we need to equal these values. So if I right-click this value and I say display as, And we see character constant W with a hotkey of R. So if I hit R next to each of these, we'll see WHAT question mark. So that is likely our password that is going to give us our positive value back and make us win. So we can check that in our command line. So let's do that now. So if we type in /keygen and we say WHAT question mark, it is indeed the correct value. So we did figure that out correctly manually doing it. But let's say now that we didn't understand this code and we needed a little bit more help. How can we get that? Well, I'm going to Command Z this all, so that way I get these back to the original values. And I'm going to hit the space bar and go back to the code. I'm going to highlight from the subroutine at the top here, the function definition. I'm going to go to the very bottom. I'm going to hit Shift to get it all and hit copy. And then we're going to open this up in an AI to get it to explain a little bit for us. So we're going to say, can you explain what this code is doing? I do not understand assembly. We can hit Shift Enter, hit 2 backticks, and paste it between the 2 backticks. And we'll hit the little arrow here. And then it says, I'd be happy to explain assembly code for you. Let's break it down step by step. And then we say, okay, the function starts by pushing the value RBX into the stack, push RBX, moves it to RDI, which we knew. And then it says it calls the string length function pointed to arg1 and stores it into RAX. It compares the length of the string to 5 in decimal. And then it says, if the length is not equal to 5, jump to this address. And then it starts checking things. If length of 5, it starts checking individual bytes of the string. And then it says it checks the first byte 77, if it jumps to there. If not, it continues subsequent bytes. So it explains to you a little bit how that assembly is working so you can figure some stuff out. And then it's got some key points at the bottom. Function seems to be performing some kind of string validation or parsing. It's checking a very specific sequence of bytes in an input string. So that's pretty much all you need to know to understand what's happening in there to start reversing it yourself. So that's one example of how to use AI in your reverse engineering. If you're super new and you have a piece of code that you don't understand, you can get it to explain it for you. Now, obviously, we're using Binary Ninja, so we can also say, okay, let's give us our high-level IL, or let's give us our pseudocode C, which is going to look more like C, and we can read this a little bit better. And you can also paste this into AI and have it explain the C code to you if you want. But that's the first example of how to do this. Now let's hop into the next Keygen me, number 2, which gets a little more advanced, and we'll get it to generate some code for us and write a keygen. So let's do that now. I have the second binary opened in Binary Ninja, and we're at the start function. So this time we're going to use a completely different reverse engineering technique and then different uses of AI, but we're going to start out similar so we have a little redundancy in what we're doing. So we are in the start function, and we're going to go towards the end of it. We're going to look for what we think is the main function, open it up, make sure that we have user code in here, and then we're going to check different things. So we're going to check we have some arguments coming in from the command line potentially. We see 2 pushes, which are probably our arguments. And then we see a user and a pass string, as well as a you lose and a you win. And then we have some code in between with a call to another subroutine, which probably figures out things that we need to figure out. And if we hit the space bar, we'll see that that looks similar to last time. Again, user pass, something happens, you win, you lose, and then we exit the program down here. Perfect. So let's take a look at the code and what's going on in here. You'll notice that it's a bit more complex where it's making decisions. We see stuff in here like a XOR with a hex value. We also see a multiple string length functions, and some different stuff going on in here. So it's a little bit more complex, but it's not too crazy. But since we understand assembly code, we can use a different way in order to figure out what's going on. We can use the pseudo C or the high level IL, which looks a little nicer. I'll hit the space bar, and what we get here is something that looks kind of like C code. We can modify this, make it look nicer so we can understand exactly what's going on. But before we do that, let's take a look at what the program looks like when we run it. So we're going to run this keygen_me2. Nothing happens, so we'll toss in a value in the arguments, and we get a user test, user null, but seg false. Might be trying to use that null value. Put in a second value. We have a user test, pass test, and then it goes to that lose. So we have these arguments, but we don't have the correct ones. So we're going to figure out what that is within the code. So if we look at this pseudo C that we have here, we have two arguments coming in, arg1 and arg2, and those are used in string length to start. But what are those values? So we'll hit the escape key, get back into main, and we'll look at the code right here. So we have a argv1, which is our first argument, and that is our username, and that's getting put into our user. And then we have our argv2, which is being put into our password down here from rbp_1, and those are getting put into our subroutine as user and then as password. So that's what those values are. And if we go into our subroutine, we could say, okay, we have arg1, we can hit N, or you can just double click it and hit username for the value, and we'll say password. And this is just for readability as we're going through our code and we're figuring things out. And then we're doing a string length of username. So this is going to be, we'll rename this one as well to user_length, and we'll rename this one to pass_length. And this allows us to understand what's going on better, because when we go down next, we say, okay, our user length needs to be greater than 1, meaning we need a user to continue. Then we have rbx1 equals 0, not sure what that is yet, but we have user length equals password length. So that tells us that our username and our password have to both be the same length in order to do any more calculations. So that's our first cue as to what we need. And then we hop into this while loop and we say, okay, rax1 is going to equal our password rbx1, and then that is going to be XORed with hex 18. So what is rbx_1? If we look down through here, it looks like we're incrementing that on each time through the loop, and it gets defined before the loop, so that is going to be our counter. So we'll say counter. And now we have our password counter, which would be 0. So our first value of our password gets XORed with hex 18, and that goes into here. So this is going to be our encoded pass character. And now this all starts making a lot more sense as we go through here. So now we have our encoded value, and we're going to put that encoded value and replace it in our current password's counter value. So we're each iteration through this loop, we're going to encode the original value from the password, and then we're going to put it back into the password at the location. So we end up at the end with the password equaling the encoded value with the hex 18 each character. Okay, interesting. And then we say if our encoded value is equal to our username at that same location, because we have the same length username as password, we're doing a bit-by-bit comparison. So our original username needs to equal our encoded characters. And if not, we're going to break out of here and fail. Okay, so essentially our password is our username encoded with this hex 18. So that gives us most of what we need. So what's left in here? Well, we have our counter, and then we're going to say if our counter is greater than the username length, meaning we don't have any more of the username to go, we're going to return 1 saying, okay, true, we have the correct value and all is good, or we're going to return 0. So we have enough information now to figure out what's going on. So let's do this manually, and then let's figure out how to make a key generator with AI in order to get this done. So I'm going to hop back into our web browser, and we're going to hop into a couple different calculators and figure out what's going on. So we have an XOR calculator, and what we need to do is take a ASCII representation with our 0x18 hex key and calculate the XOR of that. And we can't just put in test though, otherwise the value will be off. We need to do one character at a time. So we'll do calculate XOR, and we get 6C. I'm just going to type it up here for safekeeping. And then we're going to put in E for test. And we get 7D. We got S. That's going to be 6B. And then we need 6C again, and that should be our total value for TEST. Now we're going to take that, and this is our value where we took test. We XOR'd it with our hexadecimal, and we got the value which should equal test, but XOR'd. And that way we have the username and the password, but we need to get the ASCII representation of that, so that way we can put it into the terminal. So we're going to go put this into here, and this is going to do hexadecimal to ASCII, and this is the output we get. So this is the ASCII representation of test after we did the XOR conversion. So let's pop this in our terminal and make sure it works. So we got this keygen me2, we'll do test, and we'll dump in that value, which is test with the XOR to the hex 18, and it says you win. So now we know that we reverse the algorithm correctly, but now we need to automate that with Python. How can we do that without, being driven crazy? Because Python's a little weird with a lot of the conversions when you're trying to go from, ASCII with a hexadecimal. It gets kind of strange. So what we're going to do is use AI to help us do that. So we're going to go back into find, and I'm going to say in Python 3, how would I XOR a string value with a hexadecimal key so that the value test becomes, and I'm going to paste in what I had before, because I noticed when I was using some conversion tools in Python, it was giving me different values. So I'm just specifying so we get the right thing. When using the hex key 0x18, and let's see if it can do that for us. And it gives us some information here and then some code on the side. So we have this code here. It looks like we are going to take our input bytes, encode them with UTF-8, and then we're going to take our key into base 16. So we're going to take that 18, base 16, so it'll be hex. We're going to do some conversions here with XOR operation with the input byte and the key, and then we're going to return the result. So if we take this, I'm going to copy it, and let's open up a Python file here. I pasted this in here. I'm going to save it. I named it keygen test.py. We're going to do Python 3 keygen test.py, and we should get back the original test with our value. And now that's working correctly, but we need to modify this a little bit so we can put in anything we want. So what I'm going to do is I'm going to leave this hex key value up here because it's always going to be 18. I'm just going to get rid of this original value here, and we could type in anything we want. So let's do something like let's do blah blah as our value, and all we really care about is printing this out. So we're going to say print. We'll wrap this in a statement here. And this should bring us back the value we need to put in the terminal. So I have blah blah in there. We're going to hit Python keygen, and so we get back this ZTY, ZTY, and that is the correct length that matches blah, blah. So let's see if this works in the terminal. So we got blah, blah. I'm going to paste this in here, and it says you win. So now we successfully reverse engineered the algorithm. We're able to manually do it to verify that we reversed it correctly, and then we're able to use AI to make us some code that we can now modify to our heart's content and really just make this whatever way we want this to function to be a key generator. We just did very simply print out based on what we put in the value that we need, which is really all we need, but you could make it so it just prints you out tons of options, or do it command line and make it fancy, whatever you want to do. But that is the second keygen exercise. And now we're going to hop into the third one, which is a little more advanced, and get into that. So I am back in Binary Ninja, and I've opened up the third example in which we're going to do things a lot differently again. And we're in the start. Within start, if we look at it, it's pretty simple in the pseudo C version, and we just have one call to main. If we take a look at main, we don't really see any arguments coming in per se. We just see something about an email address and a serial number. And it looks like between there, it's setting something to RAX3 from whatever comes back from this sub. So within this function, it allocates some memory, about 32 hex value, into a buffer, and it uses that buffer to pull in information from the command line into fgets, and then it returns that in a buffer. So that is what is probably getting our email address here. And it looks like that's called twice, so it's probably grabbing our serial number right there. And it looks like we're submitting both of those values, serial number and email address, into here. So that is likely where all of our algorithm is that's making decisions on whether we have an incorrect or a correct serial. Hit spacebar, we can see that control flow here. We have some information grabbing our data, and then we're making a decision with this if statement of incorrect or correct. So if we take a look at this in the command line, I can run keygen, and with this one, it comes up right away. There was no arguments. So I could say test@test.com, and we'll make up a serial number. And it says, are you trying a random serial? Please don't. I have children to feed. And we get a frowny face. So obviously that's no good. We want a smiley face. So we're going to reverse engineer this algorithm. So if we hop in here and we take a look in the pseudo C, we're seeing a lot of more obfuscated code, right? This is obviously stripped or obfuscated. There's no values in here, but they're doing a lot of conversions in here between a lot of values. And we're not quite sure what's going on. We could reverse this and go through this piece by piece like we did last time, but let's cheat this time. This time, let's just grab all of this code, and we're going to let the AI help us do everything. But we're going to give it some prompts to help it help us. That way, this process is completely different than last time, and we're learning 3 different methods of manipulating data and doing things. So with this copied, let's open up the AI and paste this in here. We're going to say, can you explain what this function is doing with the 2 arguments? And then we'll hit Shift Enter, toss in a couple backticks, and paste our code in there. And it's going to go through, it's going to say this function appears to be performing cryptographic hash calculation, comparison. Let me break down the key components and explain what the function is doing. So used to accumulate the hash value, used to calculate formula, used as a loop counter. This function calculates the hash value based on the first argument, then compares this calculated hash with the second argument. And it goes through and explains each portion. So that's pretty cool. Let's say, can you convert this function to Python for me? That way we can work with it a little bit easier. So we have, let's see, sub arg1. Okay. Doing some calculations. Result equals arg2 equals hash. Compare with the second argument. So let's hit copy and we'll pop it into here. And okay, let's run this. So we'll say and we didn't get anything back because we need to actually call it. So we'll say define. Okay. And we'll just put in a random code for that. And let's see, it returns result. What is the result? Result equals arg2 equals hash. Compare the second argument. So it should give us back maybe that true and false. So let's check out that. Print whatever comes back. All right, so it comes back as false because we have the wrong values in there. So we know that. Let's look above here. We'll say format the hash as a hexadecimal string, and it's right here doing arg2 and it's doing hash string. What is that hash string? So let's say print hash underscore str, and let's get that value as well. So that gives us this here. So this might be our calculated value when associated with this test at test.com. So it's taking in our arg1 and our arg2, grabbing the length, going through this while loop. It's using the arg1, doing some shifting, putting in a temp value, var44. It's using that temp, okay. Format the hash as hexadecimal string. It's getting that hash string using that 44 that it calculated with this 40. So everything should be going in this hash string from all the calculations. So that should be correct. Let's open up this again and we're going to say keygen me 3. And this time we're going to put test at test.com. And let's see if our hash value that was calculated before based on this test at test.com and was being compared of true and false is that value. And it is. So we get our smiley face back and we now kind of sort of have a key generator. If we wanted to work this a little bit better, we could just say, okay, we don't care about the true and false here. All we really care about is returning hash string. Or actually, no. Sorry about that. We need to return hash string. We can get rid of this print function. And we could make this having a default since this is Python. So we could say arg2 equals, I don't know, test. And just give it a value. That way we don't need to put anything in. That'd be the quickest way to do this. Let me kill this. It should be good now. So now we can get rid of this because a default value is going to go in it no matter what. And we're just going to say print the hash value that comes back with just test and use whatever that default value is. Let's see what happens here. And now we have, I believe, a keygen. Yeah. So now we have a keygen program. We just feed it with anything. So testing. And we could put this as a command line argument to make it better. And we should have another value that works with testing now. Perfect. So we now have a working key generator for this keygen exercise. And we can put whatever we want in here. And we also have a lot of comments up here to help us understand what this code is doing. For example, this is showing the bit shift operation in Python. You could take a look how that's done. You know, it identified a squaring operation. You can look at that and then compare it to our original code within here. and just kind of get an idea what's going on in here by understanding the simplified code. And it's a big learning loop, so we keep understanding more and more and more, and then it'll help us speed up our reverse engineering, and we can ask for help where we need it to understand more things. So that's the point of this whole exercise, and each of these levels we looked at a different aspect of it. So hopefully all of that stuff was useful for you. If it was, share it out with your friends, and I do appreciate any likes and subscribes. And I will catch you later in the next one. Let me know below if you liked the video. Thank you.